Students, I am from Excellence EDUCARE. In the last class, we have already discussed some examples depicting covalent bonding. Okay, so in this class, we will also discuss some other important examples depicting covalent bonding. Okay, so first one is the formation of methane. This is the example depicting covalent bonding. Okay, formation of methane. Formation of methane, that is CH4. Formula of methane is CH4. Okay. So here a carbon atom, one carbon atom combines 4 hydrogen atoms to form methane, that is CH4. Okay. We have already known that atomic number of carbon is 6. Atomic number of carbon is 6. Clear? Electronic configuration EC of carbon. Electronic configuration of carbon is what? 2, 4. 2, 4. Okay. That is, it has 2 electrons in K cell and 4 electrons in L cell. Okay. Carbon has 2 electrons in K cell and 4 electrons in L cell. Similarly, atomic number of hydrogen. Atomic number of hydrogen is 1. Okay, clear? So EC, electronic configuration of hydrogen, only one electrons, that is hydrogen contains only one electron in its K cell. It has only one cell, K cell. So hydrogen contains only one electron in its K cell. Okay. So here, let us see here. Here, electronic configuration of a carbon is 2, 4. That means carbon atom has only 4 electrons in its outermost cells. That is, its valence electron is 4. Okay. So that carbon atom requires extra 4 electrons. Requires extra 4 electrons to become octet or to attain its nearest inert gas configuration, that is 8. To attain its nearest noble gas configuration, that is 8. It requires extra 4 electrons. Okay. So this is achieved by sharing 4 electrons individually, one with 4 different hydrogen atoms. Individually one with 4 different hydrogen atoms. Clear? So on the contrary, hydrogen atom, each hydrogen atom has only 1 electrons in its outermost orbit. Okay, only 1 electrons in its outermost orbit. So thus each hydrogen atom requires extra 1 electrons to become or to attain its nearest noble gas configuration, that is configuration of a helium, that is 2. Okay. So this is achieved by each hydrogen atom. This is achieved by each hydrogen atom by sharing its 1 electron with carbon atoms. That means in that case each hydrogen atom shares its 1 electron, a single electron with carbon atoms to attain its nearest noble gas configuration, that is the configuration of a helium, that is to become what? 2 electrons. Okay, so let us draw. Let us draw the picture. So here this is one carbon atom. Here hydrogen. Here hydrogen atom. Here hydrogen atom. Here we also hydrogen atom. Clear? Now carbon has 4 valence electrons. 4 valence electrons. Here clear. Hydrogen, each hydrogen atom has only 1 valence electron. Clear? Okay. Now that gives. So here carbon atom has 4 valence electron. Carbon atom has 4 valence electron. Okay. Here carbon atom shares 4 electrons individually, one with 4 different hydrogen atoms. Okay. On the contrary, each hydrogen atoms also shares 1 electrons with carbon atoms, so that both carbon and hydrogen attain their nearest noble gas configuration. That is, carbon attains its nearest noble gas configuration, that is 8. That is, so here carbon has 4 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Clear? Carbon attains octet. It's octet. Similarly, each hydrogen atoms attains its nearest noble gas configuration, that is configuration of a helium, that is 2. So in this case, you see each hydrogen atom 2 electrons, 1, 2, 1, 2, 1, 2, 1, 2. Clear? Okay. So that gives R C H4 H. Here single pair, 1 pair valence electron, 1 pair. Here 1 pair shared electrons, single pair shared electrons for single bonding between carbon and hydrogen atoms. Single pair shared electron for single bonding between carbon and hydrogen atoms. That is CHHH. That gives what? CH4. CH4. That is the formation of methane. Clear? Now formation of ammonia, NH3. Ammonia is also a covalent compound. Okay. Formation of ammonia. NH3. Okay. NH3. NH3. Ammonia. NH3. Clear? So here a nitrogen atom combines with 3 hydrogen atoms to form ammonia. We have already known that atomic number of nitrogen is how much? 7. Atomic number of nitrogen is 7. Clear? Atomic number of nitrogen is 7. Electronic configuration of EC of nitrogen 2 5 2 5, that is Kl. It contains what? 2 electrons in K cell and 5 electrons in L cell, Kl. Okay. Atomic number of hydrogen is 1. We have already known. Atomic number of hydrogen is 1. So EC, electronic configuration of hydrogen, is 1, also 1 in K cell. That means it contains only 1 electron in its K cell. Okay. So here nitrogen atom has only 5 electrons in its outermost cell. That is, its valence electron is 5. So that nitrogen atoms requires extra 3 electrons to become octet or to attain its nearest noble gas configuration, or 8. So this is achieved by sharing its 3 electrons. Individually, one with 3 different atoms of hydrogen. On the contrary, each hydrogen atom has only 1 electrons in its valence cell. That is, it has only 1 valence electrons. Okay. So each hydrogen atoms requires extra 1 electron to become, but to attain its nearest inert gas configuration, that is configuration of a helium, or to become 2. So this is achieved by each hydrogen atoms by sharing 1 electron with the nitrogen atom. This is achieved by each hydrogen atom by sharing only 1 electron with the nitrogen atoms. Okay. So let us draw. Here H, here nitrogen, N. Okay, nitrogen. Okay, nitrogen atom has 5 valence electron. So here each hydrogen atom has only 1 electron. Okay. So that gives clear. So here is the nitrogen atom. Here hydrogen. Here we also hydrogen. Here hydrogen. You just see here. Okay. So here nitrogen atom has 5 valence electrons. Has 5 valence electrons. So out of 5 valence electrons, the nitrogen atom shares only 3 electrons, individually one with 3 different hydrogen atoms. 3 different hydrogen atoms. Okay. To become octet. Here see, nitrogen has up to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Clear? To become octet. So on the contrary, each hydrogen atom shares only 1 electrons. Individually shares only 1 electrons with nitrogen to become nearest but to attain its nearest noble gas configuration, that is helium, configuration of helium, that is 2. So here see, hydrogen has 1, 2, hydrogen here 1, 2, here hydrogen has 1, 2. Clear? So that gives R N H and H and H. Okay. So here a single pair shared electron. Here we also single pair shared electron for single bonding between nitrogen and a hydrogen atom. So that is NH3 ammonia. This is the formation of ammonia, a covalent compound. Okay, NH3. Clear? So next, formation of carbon dioxide. This is also a covalent compound. Formation of carbon dioxide, CO2. Formation of carbon dioxide, that is CO2. Okay. So here is one carbon atom. A carbon atom combines with 2 oxygen atoms to form carbon dioxide. We have already known that atomic number of a carbon is 6. Atomic number of carbon is 6. Electronic configuration EC of carbon is 2, 4. That means it contains 2 electrons in K cell and 4 electrons in L cell. Clear? 4 electrons in L cell. Similarly, atomic number of oxygen is 8. Atomic number of oxygen is 8. Clear? Electronic configuration EC of oxygen is 2, 6. 2, 6. That is, it contains 2 electrons in K cell and 6 electrons in L cell. Clear? Okay. So here carbon atom has 4 electrons in its outermost cells, that is its valence electron is 4. It requires extra 4 electrons to become octet or to attain its nearest noble gas configuration, that is 8, to attain 8. Okay. So this is possible or this is achieved by sharing its 4 electrons individually, 2 electrons with 2 different atoms of oxygen. 2 different atoms of oxygen. Clear? On the contrary, each oxygen atoms, so here each oxygen atom has 6 valence electron. That is, it has 6 electrons in its outermost cells. So it has that is 6 valence electrons. So each oxygen atom achieved its octet achieve its octet by sharing its two electrons with carbon atoms. Each oxygen atom will attain octet or will attain the nearest noble gas configuration by sharing its two electrons with carbon atoms. Okay, with carbon atoms. So let us draw. Carbon dioxide. So here the oxygen. Here we also oxygen. Okay. Here this is carbon atom. It has only 4 valence electron. Carbon atom has only 4 valence electron. Here oxygen atom. Here we also oxygen atom. Clear? Oxygen atom has 6 valence electrons. Here 2, here 2, here 2. Clear? 6 valence electrons. So here we also, this oxygen atom also contains 6 valence electrons. Clear? Here carbon atoms contains 4 valence electron and each oxygen atoms contains 6 valence electrons. That gives oxygen, C, carbon. Okay. Clear? You just see here. Okay. So here carbon atom contains 4 valence electron. Okay. This cross electron. These are the 4 valence electrons contained by carbon. Here each oxygen atom contains how much? 6 valence electrons. Okay. 6 valence electrons. So here the carbon atom shares its 4 electrons individually 2 electrons with 2 different oxygen atoms to become octet. Let's see, carbon has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Clear? On the contrary, each oxygen atom shares only 2 electrons with carbon electron. Here this oxygen atom shares 2 electrons with carbon. Here we also, this oxygen atom shares 2 electrons with carbon. So that both oxygen atom attain nearest noble gas configuration. That is 8. 1, 2, 3, 4, 5, 6, 7, 8. Here we also 1, 2, 3, 4, 5, 6, 7, 8. Clear? Okay. So in this way both attain their nearest noble gas configuration, or that is C or C double bond O. So here see, here two paired shared electrons. Here what? Two paired shared electrons form double bond between carbon and oxygen atoms, between carbon and oxygen atoms. Okay, so in this way CO2 is formed. CO2 is formed. That is carbon dioxide is formed. Okay. Next, formation of sulfur molecule. Very important. Formation of a sulfur molecule, S8 molecule. Okay. Formation of sulfur molecule. Of sulfur molecule, that is S8 molecule. Okay, sulfur molecule, S8 molecule. Formation of sulfur molecules, that is S8 molecules. Okay, so let's see here. Here each sulfur atom, so we have already known that atomic number of sulfur, atomic number of sulfur is what? 16. Clear? Electronic configuration of sulfur EC of sulfur is equal to 286. That it contains 2 electrons in K cell, 8 electrons in L cell, and 6 electrons in M cell. 6 electrons in M cells. Clear? So sulfur atom, each sulfur atom has 6 electrons in its outermost shell. That is its valence electron is 6. So each sulfur atom requires 2 extra electrons to become octet. That is to attain its nearest noble gas configuration, that is 8. Nearest noble gas configuration, that is 8. Requires 2 extra electrons. So here this is achieved by sharing 2 electrons individually each with 2 sulfur atoms. Let us see here. Here each electron shares 2 electrons individually, one with 2 sulfur atoms, so that they become what? Each sulfur atom becomes octet. So let us here. So in this way, here we also only single paired shared electron form single bonding between the sulfur atoms. Okay. Here crown shaped S8 molecules. Okay. Clear? So in this way, S8 sulfur 8 molecule is formed. Okay. So these are the most important examples depicting covalent bonding. Okay. Now properties of covalent compounds. Properties Properties of covalent compounds. Okay. Properties of covalent compounds. Covalently bonded molecules are called covalent compounds. Clear? Covalently bonded molecules are covalent compounds. So some important properties of covalent compounds are first one is the constituents of a covalent compounds are molecules, not ions. First one is. Okay. Second one, covalent compounds have bond within the molecules, but intermolecular forces are weak, which is responsible for their low melting and boiling points, except graphite and diamonds. Graphite and diamonds have higher melting and boiling points. Okay. So third one is covalent compounds are formed only by sharing of electrons, not transferring of electrons. And covalent compounds have no charge, so that covalent compounds do not conduct electricity due to the absence of free electrons or ions. Only the exception is graphite, which is a good conductor of electricity. Third one. Next, fourth one is covalent compounds are generally insoluble in water, but soluble in organic solvents. Okay. But some of the covalent compounds are capable to form H bond, which are soluble in water. So these are the properties of covalent compounds. Okay. So next is comparison of covalent compounds with ionic compounds. Okay. Comparison of covalent compounds with ionic compounds. Okay. First one is covalent compounds have lower intermolecular force. Covalent compounds have lower intermolecular force in comparison with ionic compounds. Okay. Second one is covalent compounds have lower melting and boiling points. Than ionic compounds. Okay. Third one is covalent compounds do not conduct electricity, whereas ionic compounds conduct electricity in their molten state or in their aqueous solution. Okay, clear. Next, fourth one is covalent compounds are formed by sharing of electrons, whereas ionic compounds are formed by loosening or gaining of electrons. Okay. So these are the comparison of covalent compounds with ionic compounds. Clear? Say next is allotropes of carbon. Allotropes of carbon. Allotropes of carbon means allotropic form of carbons. Okay. Allotropic form of carbons. allotropes. Okay, allotropes of carbons, that is allotropic form of carbon. So what is allotropy? Allotropy is the process. Allotropy is the process by virtue of which an element exists in its different forms. In its different forms. And each different form has different physical properties but same chemical properties. These different forms of the elements are called allotropes. So carbon has the following allotropic form. First one is crystalline form. So examples of crystalline form of carbon: your graphite, diamond, fullerene. Examples are graphite, diamond, fullerene. Okay, graphite, diamond, fullerene. Clear? Next one is non-crystalline form or amorphous form. Non-crystalline form, that is called also amorphous form. So examples are coal, that is coal, lamp black, charcoal, etc. Coal, lamp black, charcoal, etc. Okay. So these are the allotropic form of what? Carbon. Okay. Allotropic form of carbons. Dear students, in the next class we will discuss general properties of allotropes of carbon, versatile nature of carbons, organic compounds, hydrocarbons, etc. Okay. So dear students, if you got some advantages from this video, please like this video, share it, and subscribe my channels, and also press the bell icon and set it all. Okay, thanks.